Hi, so today I'll be talking about depth first search, or DFS, which is a searching algorithm. You might have heard of BFS from a previous video, but we'll see how depth first search is different. So first of all, let's look at some uses. Well, there are biological uses, of course, and it helps when you're understanding the meaning in biological clusters, especially in genomics, when you cause a creation of many graphs, and when you use DFS through storing an entire graph, DFS can be useful because nodes can correspond to proteins, and you can depict relationships with the algorithm. It can also be used in topological sorting, scheduling problems, and solving puzzles with only one solution, such as mazes or Sudoku puzzles. It also helps you to discover unknown nodes by finding paths between nodes and how strong the connection is between them. Now, you might wonder, why use DFS? Well, it has less memory space, especially when compared to BFS, and even if on the first time you find the right path, it will take less time, but often it does take longer time. It helps explore the farthest possible path, and I'll go into more depth of that later. And so now here we go. How does DFS work? Well, it uses stack structure, which I've mentioned in a previous video, but you'll kind of understand how it works in this video. And it also uses this idea of pop, which I'll also go through a little bit in the future. And like I said before, it goes through an entire path before backtracking, and that's why it's called depth first search, emphasis on the depth. It knows when the algorithm is completed because the stack will be empty. So here I have an example of when you're using depth first search. So you start at layer 0 or node A, and you discover that. And this is, of course, an unknown graph. So you discover A, you put that in your visited, and you put that at the bottom of the stack. Now you can go to a next unknown visited node adjacent. So you can either go to B or C. So for this case, let's go to B. You visit B, and on the stack, you'll see how it's stacked above A. And you'll see why that's important later. So now that B is discovered, you can either go to D or E. And this is what I mean before. It goes through the path and discovers the entire path before backtracking. So let's go to D. Discover D. And now you realize that adjacent nodes are all discovered. So that's where you pop out D. Once you pop out D, you go back to B. And you'll see that E is undiscovered. So you discover E, put that in the visited, and put that in the stack. This is why you stack everything. From E, all the adjacent nodes are already discovered, so you'll pop out E, and now you're back at B, but all the adjacent nodes from B are discovered, so you'll pop out B, and now you're back at A. Now you visit the next node, which is C, because C is the adjacent node from A that has yet to be discovered. From C, you put in the visited, you put that in the stack, and you can continue. You go to F. From F, you have three possible options, so let's just say that you go to G. Once you're at G, you'll realize that all the adjacent nodes are discovered. You have to pop out G, and then you go to H or I. Let's go to H. Continuing the path, from H you go to J, and from J you go to I. You notice the entire graph is discovered, and the way that the algorithm will also know this is because now you're at I and you realize all the nodes adjacent are discovered, so you take out I from the stack by popping it. Same thing for J, H, F, C, and A. Now you realize that the stack is empty, and that shows that it is completed. And that is depth first search. Thank you.